Uh, Hi. Today we'll be discussing about microservices architecture in banking and financial system. I worked as a Java technical lead for a couple of years, so I have some idea on how to design and understand the system. And I also worked on the banking based application system architecture as well. I have implemented couple of components for microservice based banks architecture. So today we'll be discussing about how what is the need of uh, going for microservice based architecture when we have different kinds of architectural styles for building an application. So let me explain the main reason why most of the banks or financial institutes they are moving towards the microservice based architecture. Okay, so here you can see designing a banking financial system using microservice architecture. It involves decomposing the system into small independent specialized services. Whenever you are designing a particular system, you need to actually um, split that problem into different small independent tasks or services. So that's what you need to do whenever you are going for microservice based architecture. See, banking, if you take a banking application, it will have different functionalities, different modules. We may need account service. Okay, account service is a one functionality, and debit service is one functionality, credit service is one other functionality, fund transfer is another functionality, notification is also another functionality. So you have to design the domain driven model. For each domain you need to come up with the corresponding model. For each and every model you need to create a separate service. So that's where the microservice oriented architecture will come to the picture. I mean, when if we talk in the perspective of business analysis, requirement analysis, how the business analyst and product owners, they'll come up with the design and they'll take each and every functionality of a particular business problem, of particular business. So for each functionality they ask us to create a separate service. So in the monolithic architecture, we generally create a separate module for everything, and it will be again a single project, single complex project. So for the microservice architecture, we will create a separate service. Each service is independent, self-contained, and single responsibility service. So that way we can utilize that service as a separate entity, a separate object, or separate service. We can utilize or reuse that service anywhere in another service, or anywhere in or any other system, any third party system also we can utilize it. So let's discuss, so how a lead or architect, how they will actually design a banking application or system using microservice based architecture. What are the key components they'll consider? Here I'll explain you. So the key architecture always involves the below components. First thing is API gateway. API gateway is nothing but a single service. It is also another service, a REST service. It actually acts as a single entry point for all client requests, handling authentication, authorization, rate limiting, route request, and appropriate internal service. So basically, whenever the request is coming to the microservice based architecture, the first and foremost entry point service is a API gateway. So the request comes to the API gateway, and in API gateway service, we will configure authentication, authorization, rate limiting. Rate limiting means the number of requests can be processed for a particular time. No route request and routing the a request, configuring the load balancing, routing mechanisms, all these things we will configure at the API gateway. So that is the entry point service. Other component is service registry. We need a directory that always keeps the track of all available service and their network location. Okay, so that each and every service can discover other service dynamically. So the thing is, if we have a complex system, we may develop 1,000 services, 2,000, many services. Then how do we keep track of each and every service? How one service can communicate with another service dynamically? We cannot hard code the service details in a particular service, right? Should be discovered dynamically. Whenever there is a dependency of one service to another service A should be able to discover the service B dynamically, right, based on the request. So that way we need a service register where all the services, they'll register their details with the service registry. It is a directory kind of thing. It keeps all the track of all the services. And other thing is individual microservices. As I told you, for each business functionality, we need to create a separate service. For example, we are taking a banking, yes, we are discussing about banking system architecture, right? So if you take a banking system, you first take a customer. We need a customer service, right? We need a user service. We need to store the demographic information of the customer, right, user, KYC details of all the users, right? For that we need a separate service. So this service only deals with the customer information, KYC related demographic information, right? So that is why we need the customer service, user service. What about account service? Account service is it deals with the account details. So the customer can have multiple accounts. For single customer ID in a bank, you can have multiple accounts. You can open demat accounts, you can open other accounts, right? The customer ID can be same. So account service should be there. In the same way, we should have a transaction service, so handling deposits, withdrawal, fund transfer, all these things, right, should be handled by the transaction service. We can further divide this transaction service into another microservice, like deposit service, withdrawal service, fund transfer, separate services. It's up to the business case, right? If we want to make as atomic as possible, we can actually create the services. And also we need a payment service, because in the bank, right, payment processing. So how do we actually integrate external payment gateways, UPI, Shift, you can take any other third party payment gateways, right? We can integrate them. Google Pay is there, Phone Pay. So whatever it is, you can integrate any payment gateway to the payment service. You need a fraud detection service also. Sometimes we need a separate service for detecting the fraud. We can actually train some AI models, ML models on a data to find out real-time transactions that involves a suspicious kind of data. So this can be identified using fraud detection service. Notification service, generally when customer does some transaction, something happened, we need a notification service. We need to send alerts, SMS, emails, right? In the business requirement context, we need to do that. So generally you actually withdraw something or you do some online payment, immediately you will get a SMS or email, right? How we are getting it? There is a notification service in the background that always runs uh, as part of the application. So it will trigger the respective email and message with the proper data, up to date current data. So audit and compliance service ensure adherence to banking regulations. The compliance audit services, they adherence to the banking regulations. We have a GDPR, PCI, DSS, AML, anti money laundering, rules, policies. So many banking and audit compliance related service also we require. So generally the banking and financial institutions, they will implement those compliance service that adhere all these regulations and policies. So data layer is also one of the fundamental principle of the database per service. We generally need to have or normalize each and every service, so that most of the services they use a separate database. The concept is using database per service. When you go for a microservice based architecture, it is very mandatory that you should have a database per service to ensure data isolation and independent scaling, right? Services may use different technologies, PostgreSQL for core transaction, MongoDB for customer profile. For transactions, we need to follow ACID properties. We will establish foreign key relationships. We will normalize that database schema. So for that, we definitely need some SQL databases, right? That is why we may use a PostgreSQL or Oracle for core transaction related data. We definitely require a relational database. But customer profile, demographic information, just a profile, customer profile, you take just a KYC information or other data, name details, age, or some data which will be static, which is the static kind of data. So for that data, we don't need to store the data in a normalized schema database. We can store it as an object, JSON object in database. For that, we can go for MongoDB. So that way, for each service, depending on its functionality, its requirement, we can choose a separate specific databases, right? So a separate database, so that it can improve the performance. It will reduce the latency, and it will speed up the response times. It will improve the response times, throughput. So many performance related key performance indicators, we can actually improve them. Communication mechanism, okay, this is the one thing we have to discuss. Whenever you are designing a system for banking and financial applications, you may create multiple services, right? So but how can you establish communication among multiple services? That is a challenging thing. We may have a complex system which may have 1,000 services, right? How do you establish communication among services? So so generally we have generally two different ways. First way is a synchronous communication. That means you will just use some RESTful APIs, some lightweight protocols, HTTP protocol, or REST API, REST template, or REST client, or you can use Fin client for kind of synchronous communication. What it will do when for service A wants to invoke service B, service A has to wait until the response is given by service B. This is a synchronous communication, because service A is depending on the service B response, right? So if the service B is taking a 2 3 seconds, he has to wait 2 3 seconds for the response. This is synchronous communication. So if it is a small and medium sized application, and SLA for response time is moderate as per your requirement, then you can go for synchronous approach, synchronous style of establishing communication among these multiple services. But asynchronous communication, the more the complex the system is, then the more is the communication system. So then that time you may need to go for asynchronous approach, asynchronous messaging via message broker, event bus. We have a couple of asynchronous softwares: Apache Kafka, RabbitMQ. You see how it happens. Service A wants to communicate service B. In the middle, we will have a event messaging software. You take a Kafka topic or RabbitMQ queue. So service A publish a message into a queue or topic, and service B it will consume the data based on the event. So that way you can actually establish a communication. This is called asynchronous communication. In asynchronous communication, you don't need to wait for the response from the service B, right? Service A does not need to wait for the response from service B. So it is also the significant benefit of the asynchronous communication. Also, we need a DevOps and CI/CD pipelines. When you are dealing with microservices architecture, it is really mandatory and compulsory. Practice is implementing the separate DevOps and CI/CD pipelines. The reason is if you have 1,000 microservices and you don't know, I mean, which service require a change, and immediately we need to redeploy that service on the servers. Let's say for a day, if 100 services require changes, then we developer teams they will make changes and they have to deploy them manually. It may take a lot of time. It may result a complexity if you go for manual deployment. So that is why you require a DevOps CI/CD pipelines. You need to create automated pipelines or scripts, or you can use Jenkins kind of tools, other tools for deploying your services into servers. So you can also use tools like Docker, Kubernetes for containerization and orchestration that are essential for managing numerous services efficiently. So that is why nowadays DevOps became very important practice for deploying microservices in servers and managing them. So observability tools, when you are dealing with multiple services, very complex system, and they will communicate with each other, and you need to track the request. You need to understand. You need to monitor them, right? For that you need a centralized logging and monitoring tools. So Prometheus is one of the example. Grafana, you have ELK stack also. You can establish Kibana. So many tools are there in the market. You can actually try them out for establishing a logging and monitoring tools. So this is about the different key components, and I want to discuss a little bit about design patterns. So what kind of design patterns we generally use while designing the architecture of the banking system, if it is a microservice based architecture. So domain driven model, as I told you, it is the first and foremost design pattern because helps in defining a clear service boundary that align with a specific business capability, preventing services from becoming distributed monolithics. That means you need to identify the different functionalities. For banking, you need to identify what is a account service, what is a customer service, what is a fund transfer service, okay, what is a notification service. So you are identifying different functionalities, right? So you are the domain driven design, it is called domain driven design. For each domain, no, you are designing a separate service. For your domain, you are identifying the different clear service boundaries that align with specific business capabilities. So that is why you require this domain driven design pattern. You have to apply this design pattern while you are identifying the business use cases, business capabilities. You need to come up with the different services. So other thing is API gateway pattern. As I told you, it is a single entry point pattern to manage client service communication effectively, where we actually configure all the authentication, authorization, cross-cutting concerns here, routing mechanism, load balancing, so many these things we will configure at API gateway pattern. Circuit breaker pattern, we have to build a resilient services. It's not just building a microservice. Resilience means sometimes, a particular service in the middle of many services. may fail. At that time, it's um, uh, it's the services that are dependent on upstream and downstream services, may be affected because of the failure of some middle service, right? So to avoid those problems, so whenever some upstream service is using particular service, or downstream service is depending on particular service, how do you handle the resiliency? So you cannot simply show the failure thing there. You need to show some basic information, right? Until the service which was failed becomes responsive, right? Until it becomes online, we need to show some basic information, some basic details, so that we can engage the client for some time until the failed service becomes responsive or online. So that's how we have to design the microservices architecture, and that kind of design or pattern is called circuit breaker pattern. We generally use the circuit breaker pattern. We actually create fallback methods whenever something goes wrong for a particular service. If it is not responsive, immediately some fallback method will get executed. It will show some basic required details to engage the customer for some time, like this. Saga pattern is also distributed transaction management. Since every each service is having a separate database, generally microservices system, so it is a database service, the data, database per service, right? The concept. So how do you handle the distributed mechanism? It is very difficult. That is why we use the saga pattern to achieve the data consistency by coordinating series of local transactions and defining compensating actions if the step fails. Saga pattern is nothing but service A and service B are there. Service A is doing some transaction, and service B, on the confirmation of service A, service B will store the details in database, right? When service B fails, the service A should not store the details in the database, because it is a atomic transaction. There should be a consistency when storing the details. If for finishing a complete transaction, both service A and service B, both services should store the data. But in our case, if service A stored some details and service B failed, it did not store some detail, then it will be inconsistent data. So to avoid that problem, we use saga pattern. What this saga pattern will do, in case if service B fails, right, immediately it will roll back the details that are stored by the service A, right? It will roll back all those details. It will actually to make the data consistent. That way we will establish, or we will handle the distributed transactions. So for handling the distributed transaction, we require a saga pattern. Event driven architecture, as I told you, if so you want to um, loose couple the system, because there are if it is a system is very complex system, and if the establishing a synchronous communication is very difficult, then you can actually design a event driven architecture. Event driven architecture that would be useful for you. Okay. And next design pattern is the strangler fig pattern. This is also the generally we will consider as the second design pattern after the domain driven design, because whenever you want to migrate some legacy monolithic system to microservices architecture, you cannot do it at a time. You have to go step by step. First you'll freeze a certain level of requirements. Okay, you can freeze 10 requirements for the first phase, or 20 requirements for second phase. That way you can actually freeze it, and then you can migrate first phase features to microservice design, and then you can move to the next stage. So step by step we will migrate the monolithic system into microservice architecture, and that is called strangler fig pattern. Okay, and the benefits I want to go through very quickly. So agility and faster time to market, right? The development is very faster, and scalability is there. You can scale the services on demand, since each service is independent of each other, right? You can scale any particular service whenever you want to scale it, or you can actually make it proper resource utilization, and resilient fault isolation, fault tolerance. As I told you, we can create a very resilient system in case of failures, in case of outages. There should be a high reliable and continuous service availability will be there. Technology flexibility, services, we are, it is an independent self-contained single responsible service. We can actually call these services in any other third party service. Let's say service A is developed in Java, service B is developed in Python. We can establish a company, we can invoke that service. There is a flexibility, right? Since it is a JSON data we are dealing with, we can actually do that. And also enhances security compliance, security measures, compliance rules can be enforced at a granular service level, reducing the overall attack service surface. So I just want to show a simple diagram. So you can see here, see how this API gateway and other services are there. Here you see, we have a client in a content delivery network for storing static content, for serving static, identity provider for the authentication. As I told you, API gateway is the main service, and after the request goes through API gateway, it will come to the different services. And we also need this what is this discovery service, right? And then these services can call remote service if they want it, right? This is one of the architecture, and I'm just showing, but you can also see here. um, as I told you, we will have a separate database for each service, right? You can see here, this is also one of the example here. Let me show you this. Okay. And other thing is, yeah, you can actually go through the see, this is asynchronous style of communication. We have a RabbitMQ, you can see here, right? This is also a very good example. There are couple of services, they are communicating using a synchronous RabbitMQ, right? So this is also the architecture. So you can actually go through different diagram and understand how so for example, you see, for fund transfer, you can see there are three endpoints here, four endpoints: get, put to post, post, and okay, there are three endpoints, you can see here. So that way we can actually establish, create a microservice. You can see here, the user is there, there are four microservices. For each microservice there is a separate database, right? So this is what the microservice based architecture, and it will be very good when you want to create a microservice based architecture. You can see here, API gateway is there, a request is coming from web client, IoT, mobile client, and after API gateway so many services, and for each service, separate database is there. Two services are using SQL, other services SQL, right? And we also are using a message queue for asynchronous communication, right? So this is also a very good example. So this way you can actually say, here is the example: API gateway, we have account service, transaction service, user service, notification service. Okay, for transaction service, we have another, some transaction service is invoking a report service. Here you can see. Okay, notification service is also using a report service. Why do we need a reporting service? As soon as some transaction is generated or notification, we need to report that, right? So you can see API gateway, we also have, integrated with the Kafka. Service registry is there. You can, that way you can actually create a best microservice based design, you can use that. So here also you can see, I want to show you one thing here. um, Management orchestration, I told you, right? If microservice is based on synchronous architecture, then you need a orchestrator, right? Orchestrator service. Orchestrator means it will act as some orchestrator, which service needs to be invoked at which request, right? We need some orchestrator. It is a part of Saga design pattern, right? Either you can have a orchestrator, or you can utilize event based design also, right? That way you can actually do this. And other thing is, okay, let me go through if any other. um, Okay, you can see here. Okay, this is the best. You can see the clear architecture here. Typical microservice architecture. First, we are getting data from clients, and the load balancer will, it will be integrated with the API gateway. It will route your request to different services based on the load of the request. And some data, some request can go to domain A. So domain A is having three services. Domain B is having two services. What is domain here? Again, as I told you, if you take the domain driven model design pattern, for each domain we may have a different services, right? Okay, so that is what I am talking about here. So some requests are going to this domain, and these domains are talking to DBA, and domain B is talking to DBB. And what is identity provider? We will configure authentication and authorization also in API gateway. We need identity provider like Google, GitHub, Facebook. We can utilize any identity providers. Service registry and discovery is a separate service, as I told you. Each and every service should register with the registry and discovery service, so that they'll be discoverable dynamically. So service A can discover the service B, so that way they can discover, they will utilize the service registry and discovery point management. So this is all about microservice architecture. Thank you for listening. Thank you all.